The James Webb Space Telescope saw something it wasn't supposed to see. In July 2024, a team of astronomers pointed humanity's most powerful eye toward a region of space so distant that light from there has been traveling for over 13 billion years. What came back wasn't just an image. It was a problem. A massive, fully formed spiral galaxy, rotating calmly in the cosmic dark, existed at a time when the universe itself was supposedly too young to build anything like it. The galaxy was there. It shouldn't have been, and nobody knows why. This isn't a matter of interpretation. The data is clear. JWST detected galaxies that appear structurally mature, complete with organized arms, central bulges, and stable rotation, in an epoch less than 500 million years after the Big Bang, according to every model of galaxy formation we've developed over the last century. That timeline is impossible. Galaxies need time. Time for gas to cool. Time for dark matter halos to collapse. Time for stars to form, die, and distribute heavier elements. But these galaxies skipped the line. They're already old when the universe is still an infant. At first, scientists assumed the measurements were wrong. Redshift errors, calibration issues. Maybe the instruments were misreading distance. But as more observations came in independent teams, different instruments, overlapping data, the conclusion became unavoidable. These galaxies are real. They are ancient, and they are breaking cosmology. Here's what makes this so unsettling. The Big Bang Theory isn't just a story. It's a framework built on decades of observation, mathematics, and testing. We've measured the cosmic microwave background. We've tracked the expansion rate of the universe. We've calculated the density of matter and energy with extraordinary precision. Everything pointed to a universe 13.8 billion years old, born in a hot, dense state, cooling and expanding ever since. The timeline was tight, but it worked. Until now. Because if these galaxies are real and they are then, something in that timeline is wrong. Either the universe is older than we thought, which throws off every calculation we've made about its expansion, or galaxies can form far faster than our physics allows, which means we don't understand how matter behaves on cosmic scales, or the Big Bang itself didn't happen the way we think it did. And that's the option no one wants to say out loud. The galaxy that triggered the crisis is called JADES-GS-z1320. It's not alone. JWST has now identified at least 6 similar objects, all existing in the first 500 million years after the supposed beginning of time. Their light has been stretched by the universe's expansion into deep infrared, which is exactly what JWST was designed to see. But what it found wasn't a collection of small, chaotic proto-galaxies stumbling into existence. It found galaxies that look like they've been around for billions of years, smooth, stable, structured. One astronomer described it this way: it's like walking into a nursery and finding a teenager. Let's be precise about what the problem is. In the standard model of cosmology, the early universe was a soup of hydrogen and helium. No stars yet. No heavy elements, just gas slowly collapsing under gravity into clumps. Those clumps eventually became dense enough to ignite nuclear fusion. Stars were born. Those stars lived, died, exploded, and scattered heavier elements into space. That material formed new stars, new planets, new structures. Over billions of years, galaxies grew from small, irregular blobs into the grand spirals and ellipticals we see today. That process is slow. It has to be. Physics doesn't allow shortcuts, except apparently it does. JADES-GS-z1320 is not a blob. It's not irregular. It has structure. It has a disk. It has spiral arms. That means it has already gone through multiple generations of star formation. It has already distributed heavy elements. It has already settled into rotational equilibrium. All of this happened in less than 500 million years. For context, our own Milky Way is about 13 billion years old, and it's still evolving. The idea that a galaxy could reach maturity in 1/20th of that time challenges everything we know about gravitational collapse, star formation, and chemical enrichment. And here's the part that keeps researchers awake. This isn't an isolated anomaly, it's a pattern. By late 2024, JWST had cataloged dozens of galaxies in the same problematic epoch. Some are smaller, some are larger, but all of them are too advanced for their age. The statistical likelihood of all these measurements being wrong is functionally zero. The instruments have been cross-checked. The distances have been verified. The redshifts are accurate, which means the universe is telling us something we don't want to hear. Our model is incomplete. In November 2024, a paper published in the Astrophysical Journal attempted to reconcile the observations. The authors proposed that dark matter halos in the early universe were more efficient at trapping gas than previously thought. If cooling happened faster, star formation could have accelerated. The math worked barely, but it required adjusting fundamental parameters in ways that conflicted with other observations. You fix one problem, you create three more. The paper was peer-reviewed. It was respected, but it didn't feel like a solution. It felt like a patch. Another team suggested that the Big Bang itself might have been hotter in localized regions, creating pockets where galaxies could form more quickly. But that contradicts the cosmic microwave background, which shows a remarkably uniform temperature across the entire sky. If the early universe had hot spots capable of accelerating galaxy formation, we should see evidence of them in the CMB. We don't. A third hypothesis is more radical. What if the universe is simply older than 13.8 billion years? What if our measurement of the Hubble constant, the rate at which space itself is expanding, has been systematically wrong? The Hubble constant is one of the most contested numbers in cosmology. Different methods yield different results. Some measurements suggest the universe is expanding faster than expected. If that's true, and if expansion has been faster throughout history, then the universe might be billions of years older than we calculated. That would give galaxies more time to form. It would solve the JWST problem, but it would also mean rewriting every textbook, recalculating every cosmic event, and admitting that one of the most fundamental measurements in science has been off by a significant margin. No one is celebrating that possibility. And then there's the option nobody wants to touch. What if the Big Bang Theory itself is wrong? Not entirely. There's too much evidence supporting expansion, cooling, and nucleosynthesis. But what if the timeline is wrong? What if the universe didn't start 13.8 billion years ago? What if it's been cycling through phases, expanding, contracting, rebounding for far longer than we know? That's not a new idea. It's called the cyclic model, and it's been proposed before. But it's always been speculative. Until now, there wasn't strong evidence demanding it. JWST might have just changed that. Here's what makes this moment so dangerous for science. Cosmology isn't like other fields. You can't run experiments. You can't rewind the universe and test variables. You have one dataset, the universe itself. And for 100 years, that dataset has pointed toward a single, coherent story. Now, the story has a plot hole, a big one, and scientists don't know whether to rewrite the beginning, add a new chapter, or admit the story was never as complete as they thought. The tension is real. At conferences in 2024 and early 2025, researchers have openly argued about what JWST's findings mean. Some insist the solution is within reach, just a matter of refining models. Others believe we're staring at a paradigm shift, the kind that happens once a century. A few have quietly begun, exploring alternatives that were considered fringe just 5 years ago. What no one disputes is this: the observations are real. The galaxies are there, and they are not supposed to be. Imagine standing in front of a puzzle you've spent your entire life building. You've placed thousands of pieces. The picture is almost complete. Then someone hands you a piece that doesn't fit anywhere. It's the right puzzle, you're sure of that. But this piece doesn't match the edges, doesn't align with the pattern, doesn't belong to the image you've been constructing. You have three choices. Force it in and pretend it fits. Admit the picture was wrong. Or accept that the puzzle is bigger than you thought, and you've only been working on one corner. That's where cosmology is right now. JWST continues to observe. Every week brings new data. Some of it supports existing theories. Some of it makes the problem worse. In January 2025, another paper was published, showing that one of the early galaxies, CEERS-93316, contains stars with metallicity levels that shouldn't exist for at least another billion years. Metallicity is the proportion of elements heavier than hydrogen and helium. High metallicity means multiple generations of stars have lived and died, but CEERS-93316 is too young for that cycle to have completed, unless, again, time moved differently, or our models are missing something fundamental. The scientific community is not panicking. That's not how science works, but there is a palpable sense of uncertainty, the kind that comes when the ground shifts beneath you. Researchers are recalculating, re-observing, re-questioning assumptions they once considered settled. Some are excited. Discovery thrives on contradiction, but others are uneasy, because if this doesn't resolve cleanly, it means we've been wrong about the universe in ways we didn't anticipate. And here's the truly unsettling part. JWST is just getting started. It's scheduled to operate for at least another decade. Every year, it will peer deeper into the past. Every year, it will test the limits of what we think we know. If these early galaxies are a fluke, a statistical edge case that eventually fits into the model, then cosmology will adjust and move on. But if they're not a fluke, if this is the beginning of a larger pattern, then we are entering a period of profound revision. A moment when the universe forces us to admit we didn't understand it as well as we thought. Right now, we're in the waiting period. The data is in. The problem is clear, but the solution hasn't arrived yet. Maybe it will come from better simulations. Maybe from new physics. Maybe from an insight no one has thought of yet. Or maybe it won't come at all. Maybe this is one of those questions that takes generations to answer. Maybe the astronomers who solve it haven't been born yet. But here's what we know for certain. The universe is 13.8 billion years old, probably. Galaxies take billions of years to form, probably. The Big Bang happened the way we think it did, probably. And that word probably is doing a lot of work right now, more than it used to. More than anyone expected, because the James Webb Space Telescope looked into the past, and the past looked wrong.